Okay, let's try number 3. Number 3 says, if the half-life of a reactant is independent of its initial concentration, the reaction order is 0, true or false. Well, what we need to remember is that the only case where the half-life, which we write as T1/2, is independent of A initial it's only in the case of A goes to product first order. Now, we can remember that, but I'd really like to show you why that's the case. So, you will be given on the exam the following equation, among others, but you'll recognize this one. In a first order reaction, A goes to product. We know that the ln of the concentration of A at any time is equal to the ln of that initial concentration minus kT. So you might recognize this as Y is equal to mx plus b. It's a little bit rearranged, but that's okay. And so we know, for example, that a plot of the ln of A against t would give me a straight line, and the slope would be equal to the minus value of k, right? We see y is equal to mx plus b, and so the intercept there, if I were to extrapolate that up, would be the ln of A initial. Excuse me. All right, so when T is equal to T1/2, so when we've reached the half-life of this reaction, we know that the concentration of A has reached half of its initial value, so 1/2 times A initial. I could write 0.5 times that as well, but I'll write 1/2. And so what I want to do then is rewrite this equation here, and I'm going to write it as a ratio. So if I bring this over to this side, this is ln A minus ln A initial, and the difference of lns is the same as the ln of the ratio. And there we go. And so that is equal to minus k, my reaction rate constant, but now instead of t, I've got T1/2. Well, I'll write that in the next line. And so at the half-life, as we said, I've got the ln of, now A at this time is 1/2 of A initial, and the bottom is still A initial. So you can see where this is going. I'm going to have a couple of things to cancel. And now I'll write minus T1/2 minus K times T1/2. Okay, let's move this up a little bit. Hopefully we don't run out of room. I can see that this cancels, and if I plug in the ln of 1/2 into the calculator, I get a negative value of 0.693, and that's equal to my minus what I had on this side, T1/2. So if I come over here, let's just continue up here to finish this off. Let's take the negatives away from both sides and isolate for the half-life. And so I see that the half-life is simply equal to this number, 0.693, divided by the reaction rate constant, K. Now, because that's true, my expression for the half-life, that's the one, is equal to just a number divided by K. You see, in this expression, there is no A initial, and so it's true that the half-life is independent of how much is there to begin with. So regardless of how much I have initially, the time it takes for half of it to disappear is only related to the reaction rate constant. It is independent of the initial concentration. And this is only the case for reactions that are A goes to product first order. And so if we go back to number 3 and read it again, it says, if the half-life of a reactant is independent of its initial concentration, the reaction order is 0. True or false? Well, number 3 is definitely true or false. Number 3 is false. It's not 0 order. It has to be first order. Okay, let's stop it there and we'll do number 4 next.